Hello, welcome to this class. So we are looking at another aspect of research methods. So we are looking at quantitative and qualitative data analysis. Last week we discussed data collection methods. We looked at the various data collection tools, etc. Today we are looking at the analysis part of it. So this usually will fall in your chapter 4 and 5. So in chapter 3, you would have given your methodology of how you are going to collect the data and everything. You would have specified the tools you're going to use, and one of it could be or would be whether it is quantitative or qualitative data that you're going to collect it. Now we're going to look at the analysis of that data. So there are just two basic analysis methods or approaches in research methods, and that is quantitative and qualitative. The third is usually a mix. So it's either you're doing one of these or you are putting them together. Okay. So what is quantitative analysis? This is the analysis of data that you have gathered from quantitative research. And what is quantitative research? Basically, research that focuses on gathering numerical data and analyzing that data statistically to draw your conclusions on that. And this aims to quantify phenomena and test hypotheses through objective measurement. Okay, so basically here, everything statistical, everything mathematics, everything that has to do with numbers falls under this approach of analysis of data. And so quantitative data analysis is analyzing data that is numbers based or data that can be easily converted into numbers. So in whatever you are collecting data about, you want to change it or convert it into numbers so that you can look at it in terms of the numerical strength of it. And usually that makes you able to look at things more objectively, because in qualitative research, you are looking at more subjective way of doing things. And we all know that you cannot be subjective about something that is as obvious as a mathematical calculation. When you have 2 plus 2, it is 4, and it has to be 4 everywhere under the sea or in the sky. In any planet that you go, 2 plus 2 will be 2. And so you cannot say otherwise. Subjectivity has to do with how you perceive things, your point of view, how you, why you are seeing things in this way, how you are feeling about something, your experience. But quantitative, as you say it as it is, as the numbers say it. So what are the characteristics of a quantitative data? One, it is objective and it is structured. Okay, it is objective and it is also in a very well-structured manner. Numerical data. It is characterized by numerical data, numbers, mathematics, statistics. So anything that has to do with numbers is quantitative. Large sample size. We did mention last week that anytime you have a large sample size, any size that is above 25, then you must be looking at doing a quantitative research collection or a data and analysis. And also one of the other characteristics is that it is generalizability. The fact that it has tendency for you to be able to generalize on, because you are working on a large sample size. When you are doing quantitative data, you are definitely going to work with a sample. And when you have come out with certain findings on a certain sample, you can now generalize those findings on the bigger population itself. That is the characteristics that a quantitative data analysis has. It also enables you to be able to study your hypothesis. Hypotheses are basically predictions on a certain phenomenon. So quantitative data is the only data collection approach that allows you to test your hypothesis. So when you are doing your project work and you come up with a hypothesis, then it means that you are working with quantitative data. Or you have to be looking up to collect quantitative data so that you can test that hypothesis as to whether it is true or false. So now, what is quantitative analysis used for? Number one, you can measure differences between groups. For example, you can measure the average height differences between different groups of people. Number two, you can assess relationships between variables, the relationship between regular attendance of lectures and pass rates. So regular attendance is a variable, and you want to look at the relationship that has with the other variable, which is the pass rates of students. So you want to know whether when students go to class regularly, it correlates or it has some impact on their pass rates. Number three, it also enables us to test hypotheses scientifically. Now, quantitative data analysis and statistics. Statistics forms the powerhouse, or it is the data that you can use to do your statistical analysis. There's no way, if you do not collect quantitative data, you cannot do a statistical analysis. Now, two main branches of quantitative data analysis are descriptive statistics and inferential statistics. You can use one of these or you can use both. Now, descriptive statistics focuses on describing the sample. Remember that you are looking at a sample size. You have determined your sample size. You have been able to pick up a sample size, let's say of 50 out of 150 or 50 out of 1,000. Now, your objective or descriptive statistics now is when you are focused on describing those 50, the sample. Okay, you are interested in getting details of the sample, the nature of it. It's like you're having the first feel of that data. Usually the first set of stats that you will cover. Common descriptive statistics include the following: frequencies. Okay, so you want to know, usually frequency has to do with the number of times a particular value occurs within a data set or a specific category of data. So you have a data set of 100 and you have 50 said this, 40 said that, 20 said that. Those are the frequencies. Now, when you convert that into percentages, then you're looking at percentage. Okay, then there is the mean, which is basically the mathematical average of the data set. Now, the mode is mostly the commonly repeated number in the data set. So the number that has occurred a lot of times is the mode. If there is no mode, or if it's an even set of, imagine that you have a 10 set of a certain data set, that means that you will not have one that is particularly in the middle, you have two. So you have to take an average of that. Then the median is the midpoint or the middle number when the numbers are arranged in order. Remember that you have to always arrange it in order, descending or ascending, so that you can then look for the middle number. Do not pick the middle number from the haphazardly arranged data set. Then there is a range. The range talks about the measure or a measure of the spread or dispersion of numerical data, and it represents the difference between the maximum and the minimum values in the data set. Then there's the standard deviation, also a descriptive statistic, and it has to do with the spares, how dispersed a range of data set is. how close are the numbers to the mean or the average. If your average is 64, you want to see how the numbers are close to 64, or are they wide off? Are they far off from the 64? Okay. So a relatively low standard deviation means a closeness to the average. And a high standard deviation means the numbers are scattered or far off from the mean. Then there is what we call the variance. And this is the measure of the dispersion or the variability of a set of numerical data points around the mean. Okay, it's a measure of dispersion or variability of a set of numerical data points around the mean. Then there is a ranking. Ranking is the process of arranging or ordering a set of values or items based on their relative position or importance. So there is the group of descriptive data, statistical data that is usually called the measures of central tendency. There is also the measures of dispersion. And that's those of central tendency have to do with the mean, the median, and the mode. Because you realize that you are looking for about which numbers are in the center, which numbers appear most, and all of that. Those are talking about a central tendency. Dispersion has to do with the variance, the standard deviation, and now when here the mean, as we have described, it is the average, and the average is when you sum up all the scores and you divide that by the number of scores. So the number of scores are 10. If they were 20, we will add all and we will divide it by 20. Now the median, which is the middle score of all the scores in the distribution from the highest to the lowest. So here you would have to arrange them as it is arranged here, 69, 77, and so on. And when you're looking at this, this is an even number because they are 10, so you have to get the average, which is 84.5, because you will add the two numbers and divide it by 2. The mode is 77 because 77 appears the most in this data set. So take your time and do the calculation for the mean, mode, and median for these data sets. Okay, you have the mean will be 5. You'll get your median to be 4 and your mode to be 4. Do that calculation by yourself to be sure that you get these figures. Now, the inferential statistics, this one focuses on making predictions about the population. Okay, so after you have finished doing the basics or getting the descriptive statistics done, and it is crucial to do your descriptive statistics because you have to get the basis right. Everything that you do in inferential statistics has or is based on the descriptive statistics. So you cannot do without the descriptive statistics, even though that usually looks like it is inferior or it's too simple, but it is very, very necessary. And so you need to make time at every time that you gather your data to take that initial step to do your descriptive statistics so that you can then build on it. Some people do their research and they just work on the descriptive statistics. They do not do any inferential. But inferential, of course, means that you are doing a more rigorous analysis. It is important to do that. But always remember, you have to start from descriptive. And this allows you to come up with predictions about differences between two or more groups. It also helps you to establish what relationships between variables. Now, examples of inferential statistics include a t-test. And a t-test has to do with comparing the means or averages of two groups of data set. So you have, maybe you are doing a comparison of two groups. You want to take the data set of these two data sets, get their means or averages and compare them. then that's your t-test. The ANOVA is also like the t-test, but just that the ANOVA goes a step forward to do that for a multiple group, so not just two. It has to be more than two for you to be able to do an ANOVA. Then correlation analysis of the relationship between two variables is another example of an inferential statistic. And this is the relationship between temperature. That's for an example, relationship between temperature and the sale of ice cream. You want to know whether the increase or the decrease in the temperature has an impact on the increase or decrease of the ice cream sale. Now, regression analysis also has to do with the relationship between two variables, but this goes a step further to understand the cause and effect between the variables. So at correlation, we leave it at just whether there is a relationship. At regression, we are looking further to know what is the cause of that relationship. Why is this so? Now you need to get your data. When you get your data and getting it ready, what do? If you need to make sure that you are organizing the data, you are keeping all forms of the data, the questionnaire, the interview, or whatever your data is. And you want to check for competencies and accuracy. You have to go through, sort them out, and those that are not necessary, you can throw them away, but you need to report that in your report. Remove those that are incomplete. Data can be entered by hand or by computer. Okay, of course, even in the computer, you have to do some entry, the initial entry before you can start to generate your calculations. The ANOVA, the t-test, correlation analysis, all these days can be engineered by simply clicking here and there. And so it is important that you learn how to do some statistical data analysis using the various tools, SPSS, Excel, and so on. Now, when you have collected data, you have analyzed that there are ways in which you can present it for your readers to understand them. Now, data exploratory through graphical means, very important. There are some people who only understand the data when they see the way it is put. So you can do that through diagrams, bar diagram, pie charts, histogram, stem and leaf plot. You can do that by frequency plot, scattered diagram, or even a line graph. Now the vertical bar diagram or the horizontal bar. Okay, so this is the vertical bar. Okay, this is a very common one. And this is the horizontal. So it's just that it might be the same. And with a click of a button, you can have this generated. This is the component bar diagram. Okay, see that it looks different here. They are not standing by themselves, but they've been put in that way. Multiple bar diagrams, so there are multiple of them together. Then there is the pie chart. You can have the 2D or the 3D pie chart. And then the histogram does not have any spaces in them. And then we have frequency polygon. Okay, we know what a polygon is. And then we have a scattered diagram. And just plot it this way, and we're able to see this line diagram. So the difference is that this is in a linear form. Yeah. So statistical software packages, these are statistical tools that you can use to generate analysis, generate all these charts and tables and all that we have just discussed. And so one of them was SPSS, that is a statistical package for the social sciences, very commonly used by every discipline in any discipline. It provides a user-friendly interface and a wide range of statistical procedures for analyzing quantitative data. It is commonly used in social sciences, the marketing, research, and other fields to perform descriptive statistics, inferential stats, and data visualization, and also data management tasks. So for your discipline, management and HR, this is the statistical tool that is beneficial to you. Then we have the statistical software. We have the SAS, that is Statistical Analysis System. This is usually used by more of the healthcare areas. It is used for advanced statistical analysis and data management. It offers a comprehensive set of tools for data analysis, including descriptive statistics, regression, multivariates, and all of that. And then there is Excel, the common Excel that we all have can be used to generate a lot. It is accessible and user-friendly because almost everyone has an Excel on their installed on their machines. It can perform basic statistical analysis, okay, such as the mean, median, mode, etc. But for more advanced ones, the SPSS will work better, and SAS. Now there is also qualitative data analysis. And what is qualitative data analysis? It is analysis of data that has been collected from qualitative research. Now, any data that is not numerical or that cannot be represented by numbers is qualitative data. So data that cannot be measured using a fixed scale or complex statistical tool. And this focuses on the interpretation of words, text, images, videos, context, and all of that. Here you are looking at the context of the information that you have gathered, whether it's video or just in text. Now, what are the characteristics of a qualitative data? We saw that of quantitative. For qualitative, it is subjective and it's exploratory, like I mentioned earlier. Subjective because here your data set is small and you are not looking at numbers, so you cannot be objective about it. Here you are looking at what people are saying and you're reading meanings into every information, even to the tone of the voice of your respondent, their demeanor when they are answering you or listening to you, the environment, the entire behavior that accompanies the kind of data or the kind of information that is being shared by your interviewer, because qualitative data usually it's rich and detailed. Most people feel like qualitative data is the lazy way to go, or when you're not being too serious about it, but rather it's the opposite. Okay, because it's not that simple. People think that qualitative data is very easy. Okay, it's only because you are able to avoid the numbers. People don't like numbers, so when they see anything that has no numbers, it's easy for them. That is understandable. Okay, the statisticians or people who love math also find qualitative difficult. Okay, so it depends on your strength and what your objectives are. Another characteristic of qualitative data is that it is useful for small sample sizes. Like we said, any sample size that is below 25 goes with qualitative data analysis or qualitative data collection. Now, there's also the contextual understanding. Remember that one thing that makes it stand out is the fact that we read the context in which the happenings are presented to us. What are the types of qualitative data analysis? We have content data analysis, thematic data analysis, and we have narrative data analysis, discourse analysis, and grounded theory. Okay. So what is content analysis in qualitative data? Here you are using systematic analysis and to interpret the content of written, verbal, or visual communication. This involves identifying the themes, okay, the patterns and the relationships within the text or media to gain insight into the underlying messages and attitudes or meanings. So you are looking at what the content is as it's presented to you, whether in audio or in text. Okay, you are able to look at what kind of pattern, what keeps coming up, what is the issue that your interviewer or your interviewees or interview, um, your respondents, yeah, that's easier to say, are coming up with, and that you begin to draw conclusions from that. Something, a particular response by your respondent has been repeated. This person keeps saying this, or a number of people that you have interviewed keep saying a particular thing. That becomes a pattern that you want to explain in context of that response that has been given to you. Then number two, thematic analysis, a method used to identify, so you identify the themes, so that can be based on your objectives yourself, okay? You can identify certain themes under which you want to analyze the issues. And you have to identify those themes, analyze and report the patterns of or themes within the qualitative data. So remember that you are looking at the data that has been presented to you to come up with the themes. What themes are running through, as people have said this and this and that. What themes can you derive or extract from those responses? And it involves systematically coding and organizing data to identify recurring themes or patterns that represent important aspects of the research topic. There's also narrative analysis, and this is an approach that is used to study the structure, the content, and meaning of narratives or stories shared by individuals or groups. So you can listen to a whole story told to you about a certain topic that you are interested in, and so you begin to look at the narrative approach, how you can decide to just use just narrating it. And that involves you examining the plot, the characters, the setting, and the themes of narratives to understand how people construct and interpret their experiences and identities through storytelling. So this is mostly a storytelling style where you just tell, you don't have any themes, you don't have it, you're just telling a story in a certain way that will make us understand the subject matter. Now, the discourse analysis is a method used to examine language use in communication, including the spoken, written, or visual discourse. So here it involves analyzing the structure, content, and the social context of discourse to understand how language shapes and reflects social practices, power dynamics, and cultural norms. So here you are using language, basically, how people interact, how they talk to each other, what they are saying, the words they are using, the language that they are speaking. That in itself brings out certain meanings and interpretations. Then there's grounded theory. And this is is a methodology that is used to develop theories or conceptual frameworks based on the systematic analysis of data. And this involves collecting and analyzing data without preconceived theories or hypotheses. Most often we go to the field already with certain theories at the back of our minds. In fact, our entire study sometimes are hinged on certain theories. But in grounded theory, you go with nothing in your mind. You're just going out there now, going to look for the data and rather use the data to develop the theories. So you look at the theory, and based on the theory, based on the data you've collected, you will come to a certain conclusion that this leads to that, and that leads to that, and all of that. And that in itself is a theory. Okay. And that is how a lot of the theories that we know came about. Somebody did a research, and based on purely that research and the results they got from that, they drew certain conclusions that have become theories. Okay. So It is a deeper way of actually studying. So thank you for listening. Kindly let me know if you have any questions for me. You can send that through your classwork.